Those air pollutants are generated from combustion reaction, particularly happening in automobiles, combustion of gasoline, or combustion that are occurring in industrial plants. What we need to get into here in terms of the chemistry is just understanding what exactly is combustion and why they generate some of these products. So combustion reaction is really any chemical reaction where a substance reacts with oxygen gas. And this usually happens at high temperature. So whenever you burn something, that's really another word for it that we use every day. That's a combustion reaction. So when you see flame and so on. So you can burn fossil fuels, which is anything like gasoline, natural gas, alcohol, even as you'll see later, compounds that contains carbon and hydrogen. Those will react with oxygen and it actually will generate two products here, which is carbon dioxide and water. Now, before we jump further, I want to explain what I'm writing here in the middle because that's a very common type of symbolism that we use in chemistry to illustrate a chemical reaction. This is what we refer to as a chemical equation. And in order for this equation to be useful later on, you'll see we have to balance it. But as of now, this is just a chemical equation. It shows you the things that would react together. On the left side, we call these reactants, and then it shows you what you make when these two things react, and those are called products. In addition, you have these parentheses that tells you what the state of matter is of each of these reactants and products. So in this case, all of them are gases. That's why you have that letter G. If they have liquid, then you'll have L. If it's solid, you'll have S. And there are some things where we mix a compound with water, then they'll be called aqueous solution, and they have a symbol AQ. Because one of the laws that we learn in nature is what we call the law of conservation of mass, which means that the masses of the reactants and the products are equal to each other. We have to balance our chemical equation. Now, balancing an equation is a trial and error process, so you really have to develop some practice with this, but you always begin with your unbalanced chemical equation, and then you make sure that you write the correct formula, so you don't want to have the wrong formulas here, so make sure all the chemical formulas are written correctly. That's why we learn all those naming stuff earlier with the naming of covalent or ionic compounds, so that later on when you have to write the formula, you know how to write the correct chemical formula. Once the chemical formula is written correctly, you're going to try to balance this starting with compounds where there's only one type of that element. So for example, if I were to look at this particular equation, the first one I would start with is the carbon, because the carbon only appears in one compound. So the carbon only appears here. Okay, this is unlike the oxygen, for example, which appears in both of these. So you always want to start with the one that only appears one time on each side. So here's a carbon, here's also a carbon. Now, they're both one already, right? You have one carbon here, you have one carbon here. So that means they're already balanced, so you don't need to worry about that. Then the next thing you want to do is you look for another one of these elements that appear only on one of the compounds. So the next one would be hydrogen. Hydrogen appears on this compound here, CH4, and hydrogen appears here on water. Now, the hydrogen is not balanced because the subscript here is 4, which tells you there's 4 hydrogens. The subscript here is 2, which tells you that there's 2 hydrogens. So in order to make it equal, I put something called a coefficient. And that's a number that you put in front of the chemical species. So in this case, I'll put 2 right here. That number 2 multiplies into these water molecules. When I'm mixing these two, I'm going to get 1 of the carbon dioxide, I'm going to get 2 of the water molecules. So in terms of balancing, that means that we have 2 times 2 hydrogen, so that's 4 hydrogen. So that balances out with this hydrogen. So now we have balanced both the carbon and the hydrogen. The last thing we want to balance is always what we call free elements, which is the element that exists in its free state. So in this case, that would be oxygen. And that is, of course, the only one left to balance since we already balanced the carbon and hydrogen. Here we see that we have 2 oxygen on carbon dioxide, and then we have oxygen here. There's 1 only, but then remember that you're multiplying this by 2 since you have 2 water. So then you have 4 total oxygens, 2 from here and 2 from here, right? That means this oxygen gas, which exists as O2, needs to be multiplied by 2 as well. And so that would be your balance equation for the combustion of methane. Methane is this gas right here, okay? I'm going to do 1 or 2 more of these just to show you how to balance this. So for example, here's H 2O. If we start with the O here, we say, okay, well, we have 2 O's on this side. On the right side, we only have 1 O, so we need to put a 2. Now that we put a 2, we have 2 O's and 2 O's on both sides, which is fine. But then on the left side, now we have 2 hydrogens. On the right side, we have 4 hydrogens, so that doesn't work. In order to balance it, I need to put a 2 in front of this. That would balance that out, and we're done. Okay, here's something a little bit more complex. We have C3H8. This is actually called propane, so you might be familiar with that. When you're going camping, you bring these propane tanks to help you cook. That liquid that you have is propane. It has this formula, C3H8. Propane can be combusted, of course. That's how you cook, right? You take the propane and you burn it, and you generate CO2 and H2O as a product. So again, we're going to try to balance this out. We start with that element that only appears one time, which is carbon. And then we also have carbon here. To balance it, I can put 3. That would get me 3 carbons on both sides. Now the next thing I can balance is hydrogen. I have 8 hydrogens on this side. On this side, I only have 2. So to make it 8, I multiply by 4. So now I have 8 hydrogen on both sides. So the carbon and hydrogens are balanced. Okay, so once they're balanced, you really don't want to touch them anymore. Now you go to the thing that is not balanced, which is oxygen. So you have 2 oxygens here, and then you're multiplying that by 3, the coefficient. So that gives you 6. And then you have an oxygen, but multiplied by 4, so that's 4. So 4 plus 6 is 10. Here I have 2 oxygens, so to get 10 by 2, I have to multiply by 5. So that balances out that equation. Okay, I'm going to leave the other 2 for you to work on. If you have any questions, please ask.